In this video, we want to find the beta node and the beta 1, also R squared. The question is, using information in the table below, calculate the values of the estimate in A. So it's a revision question. That's why I've just written this. We had some things up there. Hope you guys can laugh at my handwriting. Anyway, the question continues. Consider the wage as the dependent variable and the age as independent variable. So if you come here, they're saying this one, the wage is the dependent variable. So this will be our y. Then the age is the independent variable, will be our x, like that. So with this question, guys, have come with my calculator. Well, let's just turn to the working page. So here we are, the working page. That is the robot. So as you can see, this is our x values and this is our y values that we have in our question. Then I've just included this and that because I want to work with this formula. But others, of course, would like to work with this formula. But I would recommend that you work with this one. Of course, this one is okay, but with me, I'm a little bit slow when I'm writing, so it takes a lot of time for me to compute this because there are so many things that are involved. But in this video, I want to show you how to do with this just in few minutes, perhaps in less than 2 minutes. So what we need to do is we shouldn't first of all start plugging in this information. Not really. First of all, we need to find this information that we have in this table or that are in the formula using the calculator. And when we find that, then later on we can plug in these values and we don't even have to use them. We just put them for formality. But otherwise, whatever we use in our working to be accurate, we have to get them from the calculator. So guys, like I said, I have come with my calculator. Let me just show you how we should do this. So here guys is my calculator. As you can see, I'm using a casual. So what I do is, before I highlight anything in here, I have first of all to solve the question. So what I'll do is, I'll just say on my calculator, I go to mode, then there, I'll go to start, which is a 2, so click 2, then there, I'll click 2 as well, selecting linear because I'm dealing with the simple linear regression, which is a linear function. So I'll press 2, like that, then it will bring me something like this. So from here, I'll enter all these variables, but maybe the calculator that you are using might not bring this. But the thing is, whatever calculator you're using, most of them have these provisions. So you just have to find a way of using these, right? Not just to calculate it manually. So what you do is, here on the x, in case you're using the same calculator as mine, so you just press the x variables, put like that, 43. And when you write, you have to press equals, just like what I've done there. So you go on to 48, equals like that. So let me just enter everything now. So when you're done, if you just want to make sure that everything is correct, so you can scroll up there and make sure that you have the same observations as your data set. And if everything is okay with your x variables, just have to turn to your y like that. Then you start entering y variables, just like what you did x variables 128. Sorry, I have to write 128. That, press that, 120, like that, and we just enter everything just right. So when you're done like that and you verify that everything is alright, so you can press read, then you want sums, so you press shift, and you press 1, so you can see that you have sum on 3, and you also have regression 5. But first of all, let's just start with a 3 on sum. So we have all these summations. So what we want to do is, for example, here I want to start with summation of x. So I'll press a 2, then equals like that. So notice that my summation of x is just 3, 3, 5, like that. Now go on to press read first of all. Now go on to summation of y by pressing shift 1, 3, then I'll press 4 equals like that. Summation of y is just equal to like that. So you have to get all these just by doing this same process. So you just get everything now. So once you're done, what you need to do is just to plug in now the information in there. So you have n, which is equal to 6 here, the observations. So it will be 6 there. Then you have there, this one. Then summation of x, you'll have that divided by summation of y, which is 8 and 10. Everything divided by 6 divided by, here you have is just a minus this one, summation of x squared like that. So when you compute the top part, your calculator, you must get this, then divided by that, then this will just be equal to round off to 4-digit figure that we have on the calculator. We will have this as our beta 1. So this is our beta 1. So now the second thing is just to get the beta 2, but we want to make sure that what we have gotten is just correct. So you can open the calculator just to confirm that. So this time around, the press shift 1 and I'll press 5. That. Then beta 2 is just a 2. So what I'll say is press 2, sorry, then equals. So you can say that even the calculator, the figure that I have is just the same. So I am pretty sure that what I've written is just correct. So I can say, okay, like that, then close it, and I go on and get beta naught. So beta naught will be given by beta naught, it will be just y bar minus beta 1 x bar. But this kind of the formula I'm using, so I'll just say summation of, what? Summation of y over n, so this is same as y bar, and this will be beta 1 summation of x over n like that. Then I have summation of y, which is just 8 and 10 over n, which is the 6, minus beta 1, I have this one here. So I'll say 9, 0.789 like that, multiplied by 3335, and this over 6, and this will be 6 common denominator. And when I compute that, I'll be left with a 491.0, rounding off to 4 digits. So I'll have that. And my final answer will be 81.84 like that. So this is our beta 2. Our beta naught like that. So just need to confirm on the calculator if at all this is what I have. So let me just get this. When I go on the calculator, I'll press shift 1 as usual, then I'll press 5. So I'll press 1, then equals. You can see that I have 81. So I can close this. So here after I have calculated everything, that's when I can go on and put in the values that are supposed to be there. So you just have to do this using your calculator. So once you're done, then that's it. You have now to go on to answer the following question, where we were asked to compute the R squared. So I want to show you how to compute the R squared just in less than 2 minutes. So let me just clear the board. So R squared is equal to ESS divided by GSS. So this one is also equal to GSS minus RSS, because this is SS, divided by total, which is GSS. So what I want to show is a very simple thing of doing this. So here you say, okay, you find first of all RSS as well as GSS. So let's begin by finding GSS. So this is given by sum of y, which is just equal to summation of y squared minus summation of the mean, the two means of y, which is squared, and over n like that. So what you do is you plug in the value for y squared, which is here. So it's a 1, 1, 2, 4, 3, and y is 8, 9, squared like that. You have your 6 there. So now when you find the common denominator, you have a 6, and 6 multiplied by this term here, then minus that, squared, you'll have that. Then when you divide, you'll have your total SS. So this is your total. So I've just decided that we use the Frank page for our continuation in terms of our computation. So we're saying the GSS we have calculated is just 649.5 like that. Then what we need to calculate as for now is just the ESS. So ESS is given by beta 1 multiplied by SX like that. So this is just the same as beta 1 multiplying uh, this summation of x. I was supposed to write y as well there. So xy minus summation of x, summation of y over n, then everything like that. So the next thing is just to plug in this, what we got. So we just need to plug in that. And that would be uh, beta 1 we had 0.9789 like that, open bracket. Then this one we had 46. So this is what we had. So after here, notice that here we have a 1. So we can take the 6 as the common denominator, then 6 multiplied by that there. We just need a calculator at this point. So let me just get my calculator. So we will say 6 multiplied by 'So what we get there divided by 6, but let's just write that one there first. So we have 2, 3, or 9. And answer divided by 3, 6, like that. So our answer will be, made a mistake, don't need to put this, we still have data. So we will have this one multiplied by 0.9789. Then we'll have 0.9789 multiplied by the final one, which is 386.5, like that. And this is just equal to equals here. So it's just equal to let's just use the breakdown. So answer multiplied by 0.9789 our beta. So we will have that. So this is 378.3385. This is our ESS. So what we need to do from here is just now to find the R squared. Let me just close the calculator. So R squared now is given by ESS over GSS. So this is just 378.3385 divided by the GSS that we have there. So that point like that. Then what will be our answer? So here we need a calculator. So here is the calculator. So we just want to delete that and just place in the figures that we have. Compute the R squared. So that is our R squared. Just need 4 digits like that. So if we multiply that by 100, notice that we have 58, then 0.25 like that percent. So in case someone didn't see that, we just multiplied that answer by 100 like that. Then we got that. So here is the final for R squared, but how do you prove that what you have gotten is correct? So well, what you do is you just delete that, then you press shift like that, then you press 1, sorry, I have to press shift 1, then I'll press regression, which is 5, then I'll press R like that. So this R is correlation. So correlation is equal to, let me just write here, correlation is equal to 0.76, I'll just write 4 figures, 2 like that. So we know that correlation is just equal to that of R. So if we want R, we just need to square this by doing this. If we square both, let me just read that. So if we square this, then R squared will just be equal to correlation squared like that. So if we square this figure, we have to make sure that we get this. So let's just square that on the calculator and see if at all we will have this. So answer squared. So as you can see on the calculator, we have the same R squared that we have here. If you check, that is exactly the R squared that we have gotten. So this shows that this proved to be more accurate as well as efficient. So guys, well, that's it for this video. I just thought about, showing you this kind of coming up with these things so that we try to improve on our racket race as we solve these sort of questions. See you. Thank you for watching.